Sample problem. 4 resistors are connected as shown in the figure. For letter A, find the equivalent resistance between points A and C. For letter B, what is the current in each resistor if a potential difference of 42 volts is maintained between A and D? First, we simplify the circuit by combining resistors or devices that are in series and parallel connection already. We see that resistors 1 and 2 are in series and resistors 3 and 4 are in parallel. For letter A, first we combine resistors 1 and 2 which are in series and we use 1. And we see that the combined resistance is 12 ohms shown in equation A. We can also see the current relationship as shown in equation B. We then simplify the parallel connected resistors 3 and 4 by using equation 5. The combined resistance is 2 ohms as shown in equation C. Here we can calculate now the equivalent resistance of the circuit which we see as a series circuit, so we have 14 ohms. For letter B, to find the current of each resistor we continue measuring the current relation to the parallel resistors 3 and 4 and we use equation 6 and get the relationship of the current shown in equation D. We further simplify the circuit to get the value of the equivalent current which we see is now in series connection with resistor 1 and 2 using equation 2. We get the relationship of the currents shown in equation E. Now we use Ohm's law to find the equivalent resistance and subsequently the currents in resistors 1 and 2. The value of the equivalent current which is equal to the currents at resistors 1 and 2 is 3 amperes shown in equation F. To solve for the currents in resistors 3 and 4 we solve first the voltage differences at points A and C and at points C and D. For voltage differences at points A and C we apply Ohm's law and we get that it is 36 volts. We then use this value to solve for the voltage difference at points C and D and we get that it is 6 volts. Since resistors 3 and 4 are in parallel connection, then their voltages are the same. So their currents can be done using Ohm's law. We see that the current at resistor 3 is 1 ampere shown in equation H and the current at resistor 3 is 2 amperes shown in equation I.